Why was DNA designed to be able to repair itself? As we saw in the previous video, the enormous length of DNA is not simply a matter of information volume. It is a spatial condition that makes time, regulation, and buffering possible. In other words, length is necessary so that reactions do not collide instantly, but can be distributed across flowing time. For this reason, DNA could not be a short code, but had to take the form of a long, extended structure. In the second video, we explained that DNA does not completely eliminate errors. The range of errors that is allowed is not perfect precision, but a boundary that permits errors without leading to collapse. If no errors were allowed at all, the structure would become excessively rigid, and even the smallest damage would cause the entire system to fail. That is why DNA requires a certain level of error tolerance. Now, when a third axis is added, the structure that sustains life finally closes. That axis is DNA's ability to repair itself. DNA does not completely prevent errors, but it also does not allow those errors to become permanently fixed. To use a human analogy, there exists a repair system like a resume of past states, multiple backup pathways, and the capacity within the structure to revert an incorrect copy. For this reason, DNA had to be long, had to allow a certain level of error, and had to be able to correct those errors. These three are not separate properties, but different conditions arising from the same requirement. If there were only length, and no allowance for error, the structure would collapse from even the smallest damage. If errors were allowed but could not be repaired, the structure would gradually decay as time accumulates. If repair were possible but length were absent, regulation and distribution within flowing time would be impossible. This is how the structure of DNA is completed. Length distributes time, error tolerance makes change possible, and repairability prevents collapse. When all three are present, DNA becomes not merely information, but a structure that sustains life within non-flowing time. However, the time referred to here is not time that flows and is consumed, but arranged time that makes operation possible. DNA functions in the present moment, but its results are revealed within the flow of time.